let's talk about the sample space. The set of all possible outcomes of an experiment is called sample space, and it is denoted by omega. Individual elements are denoted by omega, and they are termed elementary outcomes. Like for example, we take an ordinary die. The outputs of the die are 1, 2, 3, 4, 5, 6. Means these are finite. There are no other 8, 9, 10, 11 in a dice. So rolling an ordinary dice is a finite set. It is represented by an omega. In sample space, they are again two which are countable and uncountable. For countable, the example is as simple like rolling a dice or flipping a coin toss. The outcomes of a coin is either head or tails, so it is uncountable. Coming to the uncountable space, like example, we see speed of a vehicle measured with the finite precision. Here it is represented by or means it is infinite. We can't say the outcomes of an speed of a vehicle measured with an infinite precision. And coming to an event is a collection of possible outcomes and it is a subset of 1 and omega. For example, for rolling a dice, there are numbers from 1, 2, 3, 4, 5, 6, means 1 to 6. Here we can see if you want the numbers, means event E, which represent only even numbers in a rolling a dice, they are 2, 4, 6. It is a subset of an event E. In the main subset is 1, 2, 3, 4, 5, 6. It is an event E is a subset of the main event. So rolling a dice, there are two subsets. One is the numbers which are even and the numbers which are odd. 1, 3, 5 are odd and 2, 4, 6 are even. And there are mainly 5 set theory notations in machine learning. You can see the first one is if A is a subset of B and X belongs to A and therefore X also belongs to capital B. If A equal to B, so then X is a subset of B and B is a subset of A. If A union B is equal to X belongs to capital A or X belongs to capital B. A intersection B means X belongs to capital A and X belongs to capital B. And another main set theory notation is complementary, A complementary, which means X doesn't belongs to capital A elements. And these are the properties of the set operations in a set theory. One is a commutative property, associative property, distributive property, and De Morgan's property. And and in machine learning, there is mainly these type of properties in a set operations. The main important law is De Morgan, which is A union B intersection is equal to A complementary intersection B complementary. Disjoint events. The two events A and B are disjoint or mutually exclusive if A intersection B is equal to null set. And coming to the sigma algebra, let us take a given sample omega, and a linear algebra is a collection of f of subsets of the omega with the following properties. Null set belongs to capital F. If A belongs to capital F, then A complementary belongs to capital F. If A elements belongs to capital F, for every I belongs to capital N means natural numbers. Here we can see the example. Consider 1, 2, 3. F1 equal to 1 is a null set. 1, 2, 3, and 1, 2. 1, 3, 1, 3, 2, 3, 1, 2, 3. And coming to another sigma algebraic set, it is a null set and a complete set of 1, 2, 3. These are the sample space considerations for any sigma countable, either it is a countable or uncountable. 2 power omega is always a linear algebra. For example, for flipping a toss coin, the possible outcomes are 4. We can say the outcomes are head or tails, and 2 power 2, which means 4. It is a feasible sigma algebra is the power set. F equal to 1 is a null set, head, tail, and head comma tail. These are the 4 possible outcomes of an means flipping a coin. But coming to the uncountable, we cannot be assigned to every subset of a 2 power omega. Now we will look into an example. Let us consider an experiment of rolling an ordinary die, which we want to identify whether the outcome result is a prime number or not. Let us take and sample elements 1, 2, 3, 4, 5, 6. The possible outcomes F, it is denoted by F. One is null set, and one set is not prime numbers, and another set is prime numbers, and another is full set of them. Okay. F of prime numbers is equal to the total probability will be 0.5. And coming to the non-prime numbers, the possibility will be 0.5. And coming to the full elements of subset, it will be 1. And it is the bound difference inequality formula, which means f p of a intersection b greater than or equal to P of A plus P of B minus 1. It is a general form, and general form is P of union of 1 I equal to 1 to n elements of A greater than or equal to sum of P of A elements minus of n minus 1, which means it gives a lower bound on the intersection probability, which is useful when this probability is hard to calculate. Only useful if the probabilities of individual events are sufficiently large. And it is one of the main conditional probability in the set theory. Let us consider two events A and B. If P of B is greater than 0, then the conditional probability occurs, then the B is defined as, we can say the probability of A of B is equal to P of A intersection B by P of B. Essentially, the event B has occurred, it has become a new sample space. Now we will take an example of the following property. The question is, if a coin is tossed twice, what is the probability that both tosses results in heads? Gives that at least one of the tosses result in a heads. And the given subset is two heads, two tails, head and tail and head. We want two heads at the same time. P of HTT equal to P of TTT equal to P of HT equal to P of TH equal to, the probability will be 1 by 4. The total outcomes are 4, and we want one probability that the tosses result in head, which means 1 by 4. And we want the tosses results in head, which gives at least one of the tosses result in a heads. Okay, we will look into the formula P of HH by P of HT union TH union HH. The total is 3, and P of HH will be 1. 1 by 4, 1 by 3 is that's it. Let's come to the another rule, base rule. We have seen probability of A by B equal to P of A intersection B by P of B. P of A intersection B equal to P of A by B into P of B. P of A intersection B equal to P of B by A into P of B. We can, when we equal these two equations, we can write P of A by B into P of B equal to P of B by A into P of A. And coming and letting this P of A by B to the another side, we get P of A by B equal to P of B by A into P of A by P of B, which is called base theorem. That's for today. See you in the next class. Thank you.